Now that we've looked at solving linear equations with fractions, as well as contradictions and identities, we're going to do our second learn by doing activity for solving linear equations. So here, instead of just watching me solve problems, you're going to be participating in the problem solving process. We're going to do 2 problems together and then have another quick discussion about a third. So let's jump in. Solve t over 3 minus 1/2 equals 3t over 2 minus t over 5. Here we have an equation with fractions that we need to solve. What should we do first? The first step when we're solving an equation with fractions is to get rid of the fractions by multiplying both sides by the LCD, or the least common denominator. In this case, what is the LCD? The least common denominator is the smallest number that's a multiple of all of the denominators, in this case 3, 2, and 5. And the smallest number that's a multiple of all of those is 30. So we need to multiply both sides of this equation by 30. To do that, we're going to have to distribute the 30 into each of the terms on both sides of the equation. Now, there's different ways to do this multiplication when we're multiplying a whole number into a fraction. We can multiply the whole number into the numerator, and then we can divide by the denominator afterwards. There's also ways that we can cancel common factors. All of these methods work. In my experience, when we use cancellation, sometimes students tend to make more mistakes. So what I'm going to do is I'm going to first multiply the 30 into the numerator of each term, and then we're going to divide by the denominator. So here, 30 times t is 30t, and we're going to have to divide that by 3. And 30t divided by 3 is 10t. So that's what we get for the first term. Then we've got minus 30 times 1 is 30. So we've got 30 halves, or 30 divided by 2, which gives us 15. Then we'll do the same thing on the right-hand side. 30 times 3t is going to be 90t. And when we divide that by 2, that gives us 45t. And then we've got minus 30 times t is going to be 30t. We've got to divide that by 5, and 30t divided by 5 is 6t. So I just want to reiterate the benefit here of multiplying both sides by the LCD. We've now ended up with a much simpler equation that doesn't have any fractions in it. And now that we've removed the fractions, we have something that's much simpler to solve. So at this point, we can actually simplify the right-hand side because these are like terms. So if we combine these like terms, what do we get? To combine these like terms, we're going to subtract 45 minus 6, and that gives us 39t on the right. So we've got 10t minus 15 equals 39t. Now we've got variable terms on both sides. What can we do to get rid of the variable term on the left-hand side? If we subtract 10t from both sides, that will get rid of the variable term on the left, leaving us with negative 15 on the left. And then on the right, 39t minus 10t is 29t. So we've got one last step. We need to divide both sides by 29. Now, 15 doesn't divide by 29 evenly, and we can't reduce that fraction. So our final answer is just going to be negative 15/29 equals t. And there we go. Let's take a look at one more problem. Solve 3 times the quantity d plus 2 equals 3 times the quantity d minus 2. What should we do first here? The first thing we need to do is distribute the 3's on both sides to get rid of the parentheses so that we can then continue solving the equation. When we distribute the 3 on the left, 3 times d is 3d, plus 3 times 2 is 6. What do we get on the right when we distribute the 3 there? Here, 3 times d is 3d, but then we have minus 3 times 2, which is 6. Good. Now here we've got variables on both sides of the equation. What can we do to eliminate one of those variable terms? Here we can subtract 3d to get rid of that 3d on the left. But if we subtract 3d on both sides, we see that all of the variable terms cancel, leaving us with 6 on the left and negative 6 on the right. So we end up with 6 equals negative 6. What do we call a situation where we have a false equation like this? 6 equals negative 6. We call it a contradiction because 6 definitely does not equal negative 6. And what's the conclusion we come to when we're solving an equation and we end up with a contradiction in the end? We say there is no solution. There's never any situation where 6 is equal to negative 6. So that means there's no value of d that we can substitute into the original equation that will make the left and right hand sides equal to each other. So in this case, our answer is that there is no solution. Now, the last thing I want to talk about, in this problem, we said that 6 equals negative 6 was a contradiction, which gave us no solution. What happens if we were to have a true equation, such as negative 6 equals negative 6? What do we call a true equation like that? We call it an identity. And what's the conclusion we come to when we're solving an equation and we end up with an identity? In this situation, we say that all real numbers are solutions. So these are the two different situations we can end up with where we lose our variable terms when we're solving the equations. If we end up with a false equation, that's a contradiction, and we say there's no solution. If we end up with a true equation, that's called an identity, and we say that all real numbers are solutions.